Hello. I'm going to take a look at some uses of variables right now. I'm going to share my screen so I can write things down for you. So just take a moment. All right, a variable is used to represent a quantity. So X can represent a number. So in the expression 2x plus 1, we've now merged it with numbers and some operations. And we say let the x equal 10. We're now going to evaluate this. So every place we see an x, we're going to put a 10. Everything has been changed into numbers. We have to follow the order of operations here. So it's 2 times 10, which will give us a 20, plus 1, that's 21. Or, let's see here, x is equal to 22. Then we'll have 2 times 22 plus 1. That 22 times 2 was a 44. Add a 1, that's going to give us a 45. This is evaluating the variable when you know what the value is supposed to be. Now, there could be a situation where we have multiple variables showing up, say in 3x plus, hold on a moment, a mistake there, plus 5x. Both of these have an x, which means they are like terms. Like terms can be added together, and we'll take the 3 and the 5, add them together. That gives us an 8, and the x is carried along. Here you have 3 x's. Here you have 5 x's. When you add it together, you have a total of 8 x's. Or we could have 6t plus 1 plus 5t minus 2. We put the t's together, and we put the numbers together, making sure the operations match up. The t's would add up to 11. The 1 minus 2 will give us a negative 1. That is combining together some like terms. The next step in this would be the distributive property. Which says that if we have a on the outside of two things being added together, we can take both things on the inside, multiply them by that a that's on the outside. We're mixing multiplication and addition together. This gets distributed over both of the terms in there. This will be useful to us if we have a situation like this. 2 times the quantity x plus 3. Everything on the inside gets multiplied by a 2. And then we multiply together any numbers that we have left. And that's going to be 2 times 3 giving us a 6. This is the distributive property. This will allow us to combine things together. The last thing we're going to take a look at, and this is the biggest component, is solving. a linear equation. We have two properties. Addition and multiplication. If we have an equation and we add the same amount or subtract the same amount from both sides, it'll maintain its equality. Also, if we multiply both sides of the equation by the same amount or divide by the same amount, as long as it's not zero, we'll maintain the equality. So in a situation like this, we have this 1 being added in. We can subtract a 1 from both sides, and the 1 on the left side will cancel out, and a -1 will show up on the right side. We have the 2 in front of the x. We can now divide both sides by a 2, give us a -1/2. What has just happened? We solved the equation. Solving an equation means that you're going to try to isolate the variable by itself so that there's nothing else on that side of the equation. We've removed all of the numbers. There are lots of different situations where we're going to be dealing with solving an equation. Let's solve this one. 10w equals 18. On both sides of the equation, we have a number. We're going to get rid of the number in front of the w, so we'll divide everything by 10. This will give us an 18 over 10 on the right side, and the w is by itself on the left side. We can take this a step further by saying, okay, 18 is a multiple of 2, 10 is a multiple of 2. Those 2's will cancel out. Which should give us a reduced fraction of a 9/5. Now use the multiplication property. Or we can try to solve something more involved, such as a 12 equals r over 5 plus a 3. 12 equals r over 5 plus 3. We want to get rid of all the things around the variable first, working from the furthest away from the variable and working our way inward. So we're going to get rid of this 3 first. We're going to subtract a 3 from both sides. That'll give us the 9 on the left-hand side and an r over 5 on the right-hand side. Now we need to get rid of this 5 underneath the r. So we'll multiply both sides by a 5, which will get rid of the 5 in the bottom and give us a 45 on the left-hand side. That's a 9 times 5. I know I'm not showing all of the steps here, but it's important for us to start to learn to not to write down every single step. We can do a couple more here. Let's see here. 5 is equal to a -19 plus a over 3. 5 is equal to -19 plus a over 3. The first thing we're going to get rid of is going to be this 3 down here through multiplication. We're going to multiply both sides by a 3, which goes to 15 on the left side, and a 3 on the right side gets canceled out and just leaves the -19 plus the a. The only number on the right-hand side that we have to be concerned about with is going to be this negative 19. So we're going to add a 19 to both sides to get rid of that. So on the left-hand side, I'm going to write this all down. We're going to have a 15 plus 19. 15 plus 19 is going to, well, let's see here. A 5 plus 9 is a 14, plus 20 is a 34. And that'll give us A is equal to 34. We're going to have a variety of combinations that come about. We can't go through every possibility, but let's try this one, which has more terms in it. So it's a 21z plus a 5z minus 10 is equal to a 19z plus 18. We're going to use that idea from before where we combine together like terms. On the left-hand side, we have a 21z and a 5z. Those are like terms, so let's just go ahead and add them together. And that'll give us a 26z. I want to move all of the variables to the left-hand side, which means I want to get rid of this negative 10 on the left side. So we're going to add a 10 to both sides. It goes away on the left side, and if we add it on the right side, it's going to give us a 28. Now I want to get rid of this 19z that's on the right side. We're going to subtract 19z. That's essentially the same as a 27 minus 19, which is a 7. And that's going to be equal to 28. And finally, we want to divide both sides by that 7 to get rid of the 7 in front of the z. On the left-hand side, it leaves a z behind. On the right-hand side is 28 divided by 7, which is a 4. So this is how we're going to be able to solve equations. We have to isolate the variable by itself. It may take a little bit of time to do that, but it follows the same basic idea of adding or subtracting the same amount from both sides, or multiplying and dividing the same amount from both sides. There are more combinations that you can try, and you'll be able to see these in the problems later. But for now, this is a starting point that you can base all of your later work on. And that's all we have for now.